All right, we're going to be talking about fractions. So this, if you look at the title, adding fractions with like denominators, and we're actually going to slip in subtracting as well. You might say, "Oh, I know how to do that. I've been doing that for a long time, since fourth grade or whatever." Sorry, I have a thing. Um, and so it may look like review, and it is review, although we're going to sneak it up a little bit of a notch because we're going to incorporate the things that we've seen before, and that is integer rules. Because integer rules, like the adding and subtracting positives and negatives rules, and adding and subtracting multiplying and dividing positives and negatives rules, they also apply to all the other numbers, like rational numbers, and so fractions and decimals. It also later we'll find it applies to like square roots and other kinds of nonsense like that as well. It applies to pretty much anything that's a number. And so that's how that's why I have a adding fractions with like denominators in middle school A, and then I also have a adding like fractions with like denominators in middle school B. They're not, and I didn't just reuse the same video because, A, we got different backgrounds, right? This one's orange, the other one's yellow. But B is because in this one, we're going to throw in some integer rules as well. Okay, so let's jump in with examples like we often do. Okay, so we're going to start with example 1. Yeah, that's fine. Okay, example number 1. So let's do 1/3 plus 1/3, right? This we've done for a long time, so you probably know very well how to take care of this guy. With this one, since the denominators are alike, we just add the numerators, add the tops, and then leave the denominator the same. Okay, so this equals, by the way, I will kind of let the cat out of the bag. We're going to reduce our fractions at the end. You probably have seen how to do that. If not, we're gonna do some examples. We'll see in my class this year whether I end up needing to do a whole lesson on that, or whether we have experienced it enough and can get it enough that we can not do a full lesson on it. But just so you know, if that part's like, oh my gosh, just copy the notes and then let me know in class where we are with that. So anyway, so 1 plus 1 is 2, and then we don't add the denominators, so we just end up with a 3, right? That's easy peasy. We've been probably doing that for a while. That was not a big deal. Let's do example 2. We'll kick it up a notch. This time we'll just add straight up subtraction. So let's do 5/6. I hate that word. I don't know why I always use it all the time. Minus 2/6. Okay, this one, if you're jumping ahead in your head, and you may say, oh, this one's going to need to be reduced. And if you're not, that's also fine. So 5 minus 2 is, of course, 3. And then we leave the denominator the same. Now, if we look, and this is where we can reduce this fraction. Again, if we need to, we can do a whole lesson on this, and that would be totally fine. We'll see in class when I see you. If you're just watching these on YouTube, let me know in the comments if you would like a whole lesson on reducing fractions. Maybe I'll have one in the middle school A course as well. Okay, so we can divide the top and bottom because they both have a common factor. They both are divisible by 3. What's 3 divided by 3? Well, 3 divided by 3 is 1. 6 divided by 3 is 2. So 5/6 minus 2/6 is 3/6, which reduces to 1/6, right? Let's do another example. We haven't really done anything that's real integer rule-y yet. We've done some, this thing. We've done reducing fractions. Gosh, I feel scattered this morning. Maybe I haven't had enough coffee in my system yet. I don't know, something. I don't know. It's okay. We're lubing up the brain. It's not how anatomy works. Hey, how about this one? Negative. Negative in the front. It's okay. It's gonna be fine. Negative 5/11 plus 6/11. Okay. We just got regular old-fashioned integer rules, right? We're adding and subtracting integers on the top, so those rules still apply. So we've got a negative here and a positive here, so the signs are different. So we subtract and keep the sign of the bigger one. So 6 minus 5 is 1. And it's going to say positive 1 because the 6 is bigger. 1/11. Let's do another example. Let's do 8/15 minus negative 6/15. Okay. Now this guy, we've got negative in the middle, so we're going to ka-chink that guy, right? So now we've got 8 plus positive 6. So 8 plus positive 6, the signs are the same, so we add and we keep the sign, right? So 8 plus 6 is 13. So we end up with 13/15. Let's do another example. This one, let's make it a guided practice this time. Let's call this GP number 1. So this one, remember for our guided practices, what we want to do is we want to pause the video and do it and then come back and check. Make sure you're doing it in pencil. That way, if you make a mistake, when you do those, if and when you make a mistake, because you probably will on some of these, and that's one of the reasons why we do them. Make sure you're looking at the video and you're understanding where the mistake happened. And if you can't understand where the mistake happened, you can take care of that in one of 3 ways. 1, you can put a comment on this video. Number 2, you can ask, if you're in my class, you can ask on our Discord server. Number 3, you can ask in class if you're having trouble finding where your mistakes happen. So that's what we're wanting to figure out. We're wanting sometimes for you to make mistakes and then be able to figure out where those mistakes were. That's very, very helpful to your learning of this material. So GP number 1 is going to be about negative 8/12. Now you may be looking at 8/12. Think if you are good at reducing fractions already, you may be looking at that thinking that's already reducible, but I'm taking care of the like denominators part for you. So don't reduce it yet because we'll be in trouble there. Plus, let's even go with an improper fraction. Why not? 20/12. Okay, so pause the video, and then come back, and I will talk it through real quick. Skull. All right. Hopefully you paused it and tried it out. Are the signs the same or different? Well, they're different, so we're going to subtract. We are going to subtract and keep the sign of the bigger one. So 20 minus 8 is 12. And we leave the denominator the same. Positive 12, right? Because this one is bigger. Now 12/12, we can reduce the top and bottom by 12. Now you could think about that as reducing by 12, or you could think about it kind of as the rule where if we have the same thing on the numerator and the denominator, then the answer, of course, is 1. So you can think about that either way. Let's do another guided practice. And then I think we're going to be through with this lesson. So let's do GP number 2. GP number 2. Let's do 8. How about 24ths? I know that's reducible, but that's okay. Minus, let's say 12/24ths, also reducible. It's a good sign that the answer may be reducible at the end. Who knows? Maybe, maybe not. We're going to find out in a minute. All right, hit the pause button. Come back. Pause. All right, now that you're back, we've got a negative in the middle. We're going to ka-chink, right? So we've got positive 8 plus negative 12. So we've got positive and a negative. The signs are different. So we're going to subtract and keep the sign of the bigger one. Now I did this on purpose. The bigger one is actually negative this time, which means our answer is going to be negative. Now 12 minus 8 is 4. Whoops. And we have 24 in the denominator. Now this one again could be reduced, right? We could reduce the top and bottom, divide the top by 4 and the bottom by 4. And we end up with negative 1/6. End on a sad note. Stupid number, 6th. All right, we'll see you later. If you're one of my students, I'll see you in class, do your homework, all the things. If you're not one of my students, thanks for being here. Whoever you are, don't forget to like, comment, and subscribe. Bye-bye.